Test 1, 2, 3.
Loud and clear.
Test 1, 2, 3. Okay, let's see. Okay, we're good there. And
we're going to do a little recording.
okay, we'll get started. Can you all hear me okay?
Yeah, I can hear you.
Yep.
Oh, great. Okay. So good. So we got 50 out of our 90. So that's not too bad. All right. So I really do want people to try and participate in these. I think it'll really help you kind of stay up with what we're trying to do in the course. So this is micro 1. So I want to cover a number of things, and let's see if we can. All right, so let me pull up. Let me get the slides going here, and then I'm going to share my screen, and that's good. And then I don't know if I can. Yeah, it doesn't. Yeah, it's good. Yeah. Okay. All right. So I'm going to talk. I want to talk. So first off, we'll go over the syllabus a little bit. So let me do that. Let me bring up the syllabus, and we'll go back here. And all right. So here's the syllabus. Can everybody see that? Okay.
Yeah, you're good.
Yes,
Yes,
sir.
Okay, so there's a bunch of boilerplate stuff. This kind of explains what we're going to do with the with Beaver Board and Snap. So for so for this Friday, you can pick up the kit, and hopefully we'll have all the snaps. If not, we'll give you the snap later. But for $10, you get the Viva board kit, which let's see. Let me run get one just so I can go over that. I don't have one with me though. Hang on, I'll be right back. Okay, so here's the Viva board kit. I'm gonna bring up this, and let's see. Oh, have to turn that on. Makes a difference. Okay, so the Viva board kit looks like this. It comes in a little package, and then when you take everything out, there will be the printed circuit board with all the surface mount components, and that includes a whole bunch of things. So that includes the CPU right here. It's an SOIC PIC 16F1829. It's a SOIC footprint. It's got 20 pins. It's surface mount. And then we have two linear regulators. These are SOT23s. And this one converts, I think, to 5 volts. This one converts to 3.3 volts. And then you have some current limiting resistors and 2 LEDs that light up when these are active. As soon as you provide power, so the actual board, when it's put together, looks like this. And so we have a plug here that takes power from a 9-volt battery, or you can hook it up to a USB cable you don't need anymore, and you can hook it up to a USB cable you don't need anymore, and plug 5 volts in from your laptop or desktop. Then there's a jumper, a shorting block here on this 3-pin header. It's a little hard to see the 3-pin header, and you can select 5 volts or 3.3 volts. This switch, I'll show you in a minute, does not turn the power on and off per se, but it selects between this header here, which is your CR2102 dongle, which I'll show you in a minute, and this plug and the two linear regulators and this jumper. And so this just basically switches between that. The jumper switches between 3.3 and 5. You can get 3.3 or 5 off of this. You can get 3.3 or 5 off of this plug going through the 2 regulators. And so that way you can run your board at either voltage, and you still have the other voltage available on this extra pin, because you could put a DuPont wire on here and plug it into whatever you wanted to get the other voltage if you want to do that, and power an add-on device or something. So this also has these 2 transistor switch here. There are 2 transistors, a 3904 and a 3906, and then 4 resistors to bias those resistors. And then there's an input pin and an output terminal. And the input pin, the output terminal is this green terminal, and you want it to face outward, so you can put the wires in here and don't put it in backwards so it's facing in. That makes it awkward. And then you have a little 2-pin female let's see, let me turn on this light. You have a little 2-pin plug here that you can see there that you can put a DuPont wire in. If you drive, these are connected together. If you drive this high, it'll turn on and it'll give you ground and the battery voltage here. Whatever's plugged in here will show up here. If it's a 9-volt battery, you'll have 9 volts. So that lets you control things that require a little more voltage. There's the chip. We have 2 headers that bring out all the pins on the chip and dual rows. So yeah, you can plug 2 different things in. Here is an RGB LED. And then we have 4 touch buttons up here labeled U, T, S, and A. And then we have a push button here that can be jumpered. In this position, it's, if you can see, it says, let's see, switch this so that it's continuing. So it tracks. If you jumper it in this position, it says master clear. If you take this off and put it on the other 2 pins, then it configures this for the RB7 push button, and you can see it stenciled on there. And then we have some 2 resistors and a cap over here. We have a couple of despiking caps here for the chip right there, and then we have 3 current limiting resistors for the Hello World LED, and it's RGB, and it's permanently connected to 3 of the pins, but it doesn't really matter because it doesn't take much power, so that's fine. Okay, so you'll get this board, and then in addition to that, you'll get all these parts, which I'm going to show you. Here. So I've packed these myself, and I've been super careful. So when you dump them out, make sure you don't lose these little shorting blocks, because they're very small. Make sure you don't lose any of these. This 2-pin female, you should have 2 3-pin plugs, this 6-pin right angle, a 6-pin female, a 4-pin female, and then 2 double row 10-pin females. In addition to that, there are a switch and a push button, the green terminal that connects to the 2 transistor switch, and then the input for the battery voltage, the plug, and then the battery snap that goes on the 9-volt battery, and you have to connect this. You unscrew this. When you unscrew this, make sure you put these wires through so you can screw it back on when you're done. It's easy to forget. I've forgotten myself on a number of occasions. So if you forget, just unsolder it and do it over. The red wire goes to the center connector right there, and the black wire goes to the ground connector, which is this big piece here. Black to the ground, red to the center. And you just pop them through there and solder them. They just go right through the little thing. You could, if you bend the wires and put a little hook on the wires, it makes it easier to kind of hook them in there like this. And then you can even bend it further and it'll hook in there pretty good. Be careful, just use enough heat to get the solder to melt and bond nice and firmly, but not so much that you melt the whole plug into smithereens, which can be done. All right, so that's how the plug goes. And then when you're done, you can slide this thing back on and screw it back on, and the wires will be coming out there and everything will be good. If you forget to put the plastic on first, then you'll look down and you go, oh, now how do I get the plastic on? The answer is you have to unsolder the wires and do it over. So these all go in a very particular way. You really, there's only 3 things you can screw up. Okay, well, 4 things. So there's a 6-pin and a 5-pin female header. The 6-pin goes here because there's 6 holes, and the 5-pin goes here because there are 5 holes. Now you really can't get the 6-pin to fit into the 5 holes because there's 1 hole missing, but you can put the 5-pin into the 6-pin hole. Don't do that. So make sure you get those. You should probably put all these things on and make sure everything looks cool and good before you get started, and then you know you won't mess it up. So the 10-pin double row goes there. The other one goes there. The switch, it goes, you can turn it 180 degrees, but you can't turn it 90. It won't fit on 90 degrees, but it fits on great like that, and you can turn it around. This little button here, same thing. You put 2 leads through, and then you can see it's got little hooks on them. So once you get this in, actually, you have to be careful not to bend the pins up. But if you get it in, it should actually just stay in there really nicely for you, like that. Once you get that in, it's not even going to fall off. It'll actually stay there. The 2-pin terminal, again, remember the opening facing out so you can get wires in there. And then now, so the other 2 things you can, the other 3 things you can screw up. You have these 3-pin male headers and this 6-pin right angle male header. Well, the other thing you could do, you could put the 6-pin here, but don't do that. Put the male right angle header there. Now, you can put that in wrong. When you put it in like this, it sticks out nicely so that you can attach your snap programmer like I have here. But if you put it in the wrong way, if you put the long pins into the board, then you'll have these little stubby things sticking out, and that's not long enough for the programmer to hook to. And so that'll be a problem. We'll have to switch it. Sometimes I can take off the plastic block and we can still get it to work, but sometimes we just have to switch it. And if you do it, if you make a mistake and get something wrong, don't try and fix it. Just bring it to me and we'll use some sophisticated soldering equipment to make that work. Okay. And then on these 3-pin headers, the short end goes into the board. So if you put the long end in, that causes problems. You can't get the shorting blocks on them. So put the short end into the board so that you have a nice long end sticking up, and you can put the shorting block on it. And there we go. And it just looks like that. You can see it, and the long end sticking up. You can kind of see that. Again, there's a short end and a long end. Put the short end into the board. And the same for the other 3-pin header here. This 3-pin header selects the voltage that the chip's going to run at. This 3-pin header selects whether the push button is used as a master clear button or as a pin RB7 input. And we're going to use it a lot as an RB7 input. We probably won't use it very much as a master clear button, but it's nice to have that. And then this pin here just goes there. Note, everything goes on top of the board. Nothing mounts on the bottom of the board, but on the bottom of the board, you're going to do all your soldering. If I turn it over, the stuff's going to fall out. But if I bend this so you can kind of see the bottom of the board, maybe you can see that all these pins stick through, and that's what you're going to solder. And you're going to do all your soldering on the bottom, but all your parts should be on the top. And when you open up the package, you should check and make sure that you have. So counting the, like I said, that one's hard to get off. Counting the board, so you should have the board plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Should be 16 parts plus the board, or 17 things all totaled if you want. And if you're missing something, let me know. We have plenty. But I will tell you, I personally packed these. I was very, very careful. So the likelihood you're missing a part is very small. It's not 0, but it's very small. So if you're missing a part, make sure you didn't dump it out and lose one of these little shorting blocks, or one of these little 3-pin headers, or maybe the 2-pin header, or the 5-pin header, or the little push button, or the little green terminal. The rest of these are pretty big, a little harder to lose, but you could lose that one. And you could lose the 6-pin. Probably wouldn't lose one of these, or the plug, or the battery snap. Okay, and then I'm going to put these back in the bag, and away we go. So the bag should say Viva board fall 2020. Oops. Fall 2021. This is revision 4.4. We've been through a number of revisions. We've been through 4 major revisions. And then on this final 4th revision, we've revised it 4 times. So, and we'll probably do another revision for next semester. That's going to be another major. So it will be 5. It'll be the Viva board 5.0 or maybe 5.1. Hopefully, that's the plan. So when you're using the board, we're going to give you this packet. We're also going to give you a plastic tray. There may be some water soluble glue on the back you can wash off before you snap it in, and you just snap it in. When you snap your Viva board into this, it's pretty easy to get it out. You might need a little screwdriver to do it. It just takes a little prying to pop out one side, and then it just slips out. The one thing I want to show you is it's not a perfectly symmetric thing. This end has rounded corners, but the corners on these things are squared off. We had to go in and modify it because these pins stick down just a little bit, and you wouldn't be able, if you put it in backwards, it won't fit quite right. And to put it in, you just slide it underneath there. In fact, it's probably better to slide this edge in like this, and then just push this side down. Let's see. Yeah, takes a little bit. It's a pretty tight fit. It won't come out accidentally. Took a few printings to get these right. You can, if you want, there is a provision to put an M3 bolt and nut. The nut fits perfectly in here and recesses. And if you get the right size M3 screw, then the nut will be pulled up flush in here and it won't stick out. But you don't need to do that because it's mounted very tightly this way. Okay, we're going to give you this in the case. We're also going to give you a snap programmer, which looks like this right here. And you can see that the snap programmer fits right here. If you look at the case we print for the snap, there's an arrow in it, and it'll match up with this arrow. When you put the case on the snap, make sure you get it lined up correctly. I should have bought a case. I don't think I have one in a case here. I have to run out to the garage to get it. Maybe I'll do that at the end. But anyway, you drop it in and then you snap on the case. When you snap on the case, there's 2 little bitty LEDs right off the end of my finger there. Make sure that those LEDs are underneath the little oval window and that the arrow to show how to get this lined up is right over this end. This end plugs into your board. This end plugs into a micro USB cable, which we will also give you. So we're going to give you a micro USB cable. We're going to give you the snap. We're going to give you a case. We're going to give you the Viva package, the Viva kit. We're going to give you a case for the Viva board, and we'll give you a case for the snap because they come like this. They're just kind of sticking out here. So rather than have them just exposed, we'll give you a case to protect it a little bit and a cable. So that's what you get for $10. So bring in $10. If you can bring in a $10 bill, that'd be great. We don't have the ability to take credit cards. So it'd be, but later in the week, we may have the IEEE bin sell them. And in that case, it may cost you $11 in the IEEE bin because we'll let them charge $1, which they'll use for pizza for IEEE purposes. Okay, so we're also going to loan you 3 other pieces of equipment that you can that will be useful. One of them is the CR2102 dongle. Well, okay, so there's several things. So one of them is this 2 line by 16 LCD display. You can see it's showing temp of 29 and 21 here. It's a little hard to see it. You can see it better if I block some of the light. And these work really nicely. They have on the back of them a buddy board that enables this to be driven by 2 lines from the microprocessor using the I2C protocol. And we'll give you the headers and all the commands you need to run this display. And one of the labs, I think it's lab 10, will do that. And then you probably will need to use this display in your final project. Okay, we'll also give you this analog board. It plugs into the analog header right here. You can plug other things in the analog header, but this board's all set up. It has power, ground, and then it has 3 analog inputs. One for this, the MC 9700 temperature sensor, one for the potentiometer, and one for the photoresistor that's set up in a little bridge circuit. I'm going to stop this thing from jumping around. Okay. So one of the labs you do, you'll read in the temperature, you'll read in the pot, you'll read in this. We did this because if you put the pot in backwards, you can, hook the pots in wrong, you can burn them up. And so we finally got tired of having all the pots burned up. So we made this little board. And then we also added the temperature sensor and the photoresistor. And you can't really plug it in this way. And even if you do, it won't screw anything up too bad. But obviously it goes in like this. Like that. And once you get it plugged in, everything's cool. And then you can do your lab. The other thing that we'll give you is this CR2102 dongle, and it's plugged in here. It comes in 2 flavors. Some of them have the right angle connector, which they actually ship with the chip. And then some of them have straight pins. If they have straight pins, they mount like this, and it actually works a whole lot better. If they have these right angle pins, you have to stand them up, and you can put them in backwards. You have to stand them up like this. Now, what you should do is look at the stencil down there, and you'll notice that all the various pins are listed here: 3.3 volts, DTR, MCU transmit, MCU receive, ground, and 5 volts. And here you see the same thing: 3.3 volts, DTR, RX, TX, ground, and VCC 5 volts. Do not plug these in facing this way because they will burn up. If you do that, they'll just burn up instantly. And in all fairness, it does look like it should kind of go like this, right? This kind of looks reasonable, but it's not. It goes in like that. The lettering faces the microprocessor. So the back of the board faces out, which just seems kind of backwards. So that's why we've tried to modify most of them so that they plug in like this, where it's really hard to put them in backwards. It doesn't make sense to put them in backwards. Okay, so this will, once it's plugged into your desktop or laptop with the micro USB cable, which we'll also give you with this, then you can actually power the board from this. So in that case, I can put the switch in the other position, and I can unplug the battery, the 5 volts in this case, and it'll still run. Whereas if I go back to this, now there's no 5 volts, it turns it off. But if I plug this back in, it's back on. If I have it here and I unplug this, then it will go off. So it definitely works. Now, what's really a little confusing is if I have it plugged in here and I take this out, then you can still see the RGB LED is still working, the chip's still working. Do not run it in this mode. You want to run it in that mode, because when you run it in the other mode, it's providing the power through one of the transmit and receive pins, I guess probably the receive pin. So that's not ideal. It's running too much power through one pin, and it could cause problems with the microprocessor having trouble. But I've certainly left it like that accidentally, and it doesn't seem to kill it, so that's good. But don't do it intentionally. So if you're running it with this, if you have this plugged in, then either make sure your battery's plugged in and you're running it with the battery, or make sure you're running it in this position. Now, what I would recommend you do is always run it with your battery. And then, but you can use this if you want, but if you do, make sure it's in the inner position. If you're going to use the battery, that's fine. Then have the switch in this position. But remember this, no matter what position the switch is in, see if I go to this position, notice these lights are still on. The battery is still supplying power to the LED through these linear regulators and driving these lights. And if you leave that, even if you switch it, like if this is unplugged, the lights will go out. but the battery is still providing power to these linear regulators. And they're now not driving the lights, but they are driving the linear regulators. And so overnight, if you have a battery plugged in here, it'll run down. So if you want to save your battery, when you're not using it, unplug it. That's the only way to keep your battery from draining. Whenever the battery's plugged in, regardless of the switch setting, it is, these linears are sucking some power out of the battery, enough that overnight it'll run the battery down to the 0. Okay. We have labs set up to use all these parts, and we will loan these to you. We'll loan the LCD, we'll loan the CR2102, we'll loan the analog thing. We'll also give you the cable and some DuPont wires to use. I don't care about the DuPont wires, but please make sure you turn back in the displays, the CR2102s, and the analog modules. I have to solder these up by hand, and it's not horrible, but it takes time. And I just soon not have to solder up some more. And then eventually I'm going to run out of my components and have to order more of those. So it's really helpful if you can turn these back in so we have them. The LCDs are $5 a piece, so they're not super expensive, or maybe a little more than that, maybe $6 a piece. But in any event, if we don't get them, then I have to buy more. That gets expensive. When you buy 10, that's $60. So so it adds up. And then these are about $3 a pop. So it's really nice if, or maybe a little more. It's really nice if we don't have to do that. The snaps, we do get them at a pretty good discount from Microchip, but if you just go out and buy them, I think they cost about $26, something like that. So you do want to be careful with them. You're getting them at super discounted prices. And these will program most of the parts that almost all the parts Microchip makes. There may be some it doesn't, but almost all the parts it makes, it'll program. So it's really nice. This will not power the part though. You have to power the part with either the battery or the CR2102. Okay. And in order for any power at all to get to the chip, this jumper must be in place. If it's just missing and the pins are sticking up there in the air, your chip will never run. You won't be able to program it. It won't do anything. You have to have this on either the 5-volt setting or the 3.3 setting. For most things, you can pick either setting. If you use this device, that has to be powered at 5 volts. So it's then you should run your board at 5 volts. And then you can power this device. You can get power from the pin on the end here, and you can get ground from the end of the pin here, or you can get it from this header because it has power and ground, unless you're using it for something else. You cannot get power from this header because that header only connects to the switch. So if the switch, depending on what position the switch is in, you may not get any power at all from this header. So, and of course, this has to be plugged in to get any power from it. So don't try and power anything with this header. Okay, I think that's what I wanted to say about that. So again, what you're going to get are these two things plus the 2 plastic cases for 10 and the cable, the micro USB cable for $10. And that's what we're going to do on Friday. Let me stop there, and I'm going to quit sharing, and I want to see if there are questions about that. So go ahead with your questions. Let me look at the chat, maybe.
Where can we get this? Is it on campus or do we have to order online through you?
No. Just come to the laboratory on campus. It's in the engineering building. It's on the 2nd floor. It's in the main hallway, which is hallway 4, and it's room 22. But if you just walk down, if you walk in the main door of the engineering building on the 2nd floor, walk up and down, you'll see activity. On Friday, the way we run the lab on Friday, we run the lab from 10 a.m. to 3 p.m. I have classes at 9. I have class at 11. So I'll be stepping out for those classes. I won't be there the whole time necessarily. My TA also has class 11, but we have an undergraduate helper that's very experienced. He's super, super good. He's done this the last, I don't know, 2 years, I think, anyway, long time. So he can help you totally. So, and he has keys for all the parts and stuff. So, so you can come in, you're assigned some recitation section, either 10, 11, 12, 1, or 2. But you don't have to come to one of those. You can come anytime between 10 and 3. And you can work until you're done and then leave. We will try and kind of, if it's super crowded, we may ask some people to wait in the hall until the numbers drop down a little bit. We're going to try and be mindful of our COVID situation. We do ask you, we'd like you to wear a mask. You don't have to, but we'd like you to wear a mask and just minimize, the risk of transmission. And if you're not vaccinated, I do recommend you get vaccinated. I think it's probably, well, they finally did give full FDA approval to the Pfizer vaccine, and I think the Moderna is on the way. So the Pfizer is now an approved vaccine, no longer an experimental vaccine. So I think you can with confidence do that. But you don't have to, it's still your choice. I'm not, there are some people who medically probably should not take the vaccine. I had COVID and I got 2 shots of Moderna, and I suppose I'll do the booster when it comes out. There are some concerns voiced by legitimate people, but I think our experience so far has been that, well, and of course, the problem with any vaccine is, or with any medicine is, if millions of people are given it, somebody's going to drop dead, the next day. Well, they might very well have dropped dead the next day anyway. We don't know. So then it's hard to know if the vaccine caused that dropping dead, or if the dropping dead was just a random event unrelated to the vaccine. I don't know. It's certainly concerning. They need to look at all those events and see if there can be any causal link established. And at this point, I'm comfortable with it, but obviously I think that's every individual's choice. Although now that it's an approved vaccine, just like we mandate that kids that go to school are vaccinated with measles, mumps, MMR, rubella, so MMR, and then also, I guess, tetanus, I don't know, whatever the kids get, Tdap and DAP, I forget, there's a whole bunch of different, they get whooping cough and anyway, so, and then we also vaccinate kids for chickenpox, whooping cough, and a bunch of stuff. We don't vaccinate for smallpox anymore, but if smallpox got out, it would be devastating because we have so many unvaccinated people. So, but fortunately, smallpox has been eliminated from the wild, but it still does exist in, I think, 3 or 4 biocontainment labs around the world. So it could, it has occasionally infected a lab worker, but I think they make them all get, they would be wise if they made them all get smallpox vaccinations. But the problem with smallpox vaccinations, there were an occasional person that had bad immunity, and they would actually die from the vaccination. So that did happen, and that's one of the reasons why when they eliminated it, they stopped vaccinating. Okay, well, anyway, let's see what else. Okay, so let me stop. I'm really curious if anybody, surely somebody's got some questions, some other questions.
What language
So-
are we going to use?
Go ahead.
bro.
Okay. I was going to ask, what language does the programmer use?
Okay, so the programmer is not language constrained. Every time you write a bit file into the microprocessor, the PIC16 F1829, you're always writing it in machine language.
Oh, right.
So there are compilers out there that will compile C code, assembler code, basic code, probably Python, although I haven't seen one for Python, but it's probably out there now and will be soon if it isn't. So there's all sorts of compilers available. But what we're going to do in this course is the first 6 labs, you're going to program in an assembly language. which is exactly what is written into the board, except when you use assembly language, the only difference between assembly and machine language is in assembly language, for instance, if you want to have a no operation instruction, you can write NOP. If you were writing machine language, you'd have to write the actual hex code. Every single instruction for this processor is 14 bits, every single one. There are no instructions bigger, there are no instructions smaller. They're all 14-bit instructions. And so this is a great chip to learn assembly language on because it's a fairly straightforward assembly language, and you can fully understand what's happening in this chip, which means once you learn this chip, you can then extend that knowledge to any microprocessor because they all are basically very similar. I think I used the analogy of shoes the other day. This processor is kind of like a pair of flip-flops as opposed to some high-tech boots with rollers in the back and flashing lights. But in the end, a shoe is a shoe. And that's really true of microprocessors. They all have program counters. They all have general purpose registers. They all have all of the embedded processors have flash memory where the program is stored. They all have random access memory where variables are stored. They all have a stack, and they all have status bits. They all have interrupts, and it's just different degrees of complication, but the basic principles are exactly the same. So once you learn one, you really understand all of them. And that's why it's powerful to learn one. If you never learn one, you basically don't understand any of them. After we finish those first 6 labs, then we will shift into C, C++. So you'll be able to write your instructions in C. The compiler can handle, I think, some C++, but mostly it's a C compiler. Let's see. And so mostly we'll just write in C. We won't be writing programs so big that we'll have to, deal with lots of inheritance and things like that. We'll mostly just be, there are some nice features of C++, but we'll probably have to declare our variables before we use them, like in a for loop. Okay.
Yeah. So I've watched people write in assembly language and all that, and I'm just not super comfortable with it yet, but I'm excited about it.
Yeah. Well, right. I wouldn't expect anybody taking the class for the first time to know PIC assembly. Yeah. There's actually, so the microchip family has 8-bit processors, and then it has sort of the elementary 8 bits, the mid-level 8 bits, and then the advanced 8 bits. So this is a mid-level 8-bit. The advanced 8 bits are PIC 18s, and then it has 24-bit processors and 32-bit processors. And the assembly language differ between those, and the features differ. But once you learn this, you'll be like I say, there's 40. I think there's 49 instructions in the assembly language set, and there are a few of them we don't have to know. We're not going to do indirect addressing, although it's pretty straightforward. So that'll save us a little bit of work. But you're going to learn the basic commands, and you're going to find some of the commands are nice, are more convenient than C. But you're also going to see that if you have to deal with floating point numbers or even a lot of numbers, any complicated mathematics, it's just a super pain to do it in assembler. For simple math, you can do it in assembler, but for complicated math, you can't. And if you're working in assembler and you want to do a little bit of math, we usually do binary coded decimal. That's what we do. But even that requires some special programming to make it work right. Okay. Any other questions?
Yeah, I had a question here. I have the VivoBoard revision 4.3/4.
So
will this still work, or would I have to get the 4.4?
Yeah, so it's only $10. I'd like you to get your own board instead of using a buddy's from a previous semester, and I'd like you to put it together yourself. I think that's an important experience to have in and of itself. So I'd really like you just to go ahead and do this.
Well,
Um,
I'm retaking your class, by the way, so
Yeah.
that's what I'm saying. It's wrong.
There are a couple of differences between the 4.3 and the 4.4.
Okay.
So we moved we moved the line for the push button, and the lettering is now you can see the letters, whereas on the other one you can't. So I think you'll be better off if you just go ahead and use use this board. Okay.
Thank you.
Do you expect us to bring our own soldering equipment, or
Oh.
is that going to be provided?
Good question. Yeah, and I saw a few questions in the chat room too. So let me address that. So we will have what I'm planning on doing on Friday is trying to divide it up a little bit and have some stuff set up down in the maker space, and also some stuff set up in the lab. The lab is not super conducive to soldering because you got all the computers, the desktops are already all there, but you can do it, and we did a lot of it last semester. But the makerspace is really nice. They have soldering stations down there, and they even have some fume suckers, and you can spread out. So my goal is to try and have some stuff set up down there. So come to the lab first, and then get your kit. And then if there's room, you can stay there and solder. We'll have some solder station set up. We might even have some stuff set up on the third floor lab. I don't know. Or we may have some stuff set up in the maker space so you can go solder there. So we'll sort of play that by ear. I'm not sure, but for sure we will have some solder equipment available. And then it takes a good 30 minutes to get all the parts soldered on if you're kind of just starting. I will if we have time, yeah, I don't know. I may solder on. Well, I don't know. We'll see. I'll try and do a little solder demo at some point. So yeah, I'll try and do a little solder demo.
Dr. Morton,
Yeah,
I have a question.
Yeah.
If I have my own soldering iron at home, am I able to come just pick up the parts and then solder at home, or would you prefer?
Yes.
it in the
No,
lab?
that's fine. You definitely can do that.
Okay, sounds good. Thank you.
Yeah, and
Yeah, 'cause
again,
I had
go
I had
ahead.
a big one that I used to use when I'd fix the Pokemon games and everything.
Yeah,
And I didn't know if you prefer us to bring our own, or like how he said, just you can grab it and you can dip out.
yeah, go ahead and bring your own. And to do this work, you do need it has to have a fine tip on it. If you have like a real big tip, you'll find it very difficult to do it. So you need a tip that looks where the size of the tip is, something like that. If you have a lot bigger tip than that, then you'll be struggling.
Okay, kind of like a needle for like a tattoo needle kind of thing.
Yeah, about that size. Well,
Okay.
you can see about how that compares to my finger, right?
We can't see it on the.
Yeah, okay.
Oh, sorry. I'll share my screen. I keep forgetting you can't see that unless I share. Sorry. Yeah. So like that.
Oh, okay, flat. Okay. Pointed tip.
So it's not like a needle, but yeah, but it's fairly small.
That's exactly the one I would use for fixing the games. So it works out.
Perfect. Yeah. Yeah. So, and if you've got some experience soldering, then that's all the better. Let's see if I see if I have one. We'll yeah. Okay. So let me stop sharing. Okay. Any other questions on that? I think so. I'll try and do a little demonstration soldering. Maybe I'll do that.
Professor,
Yes.
I do have one last question.
Okay.
I will be leaving town Thursday, and I'm currently at the lab. They told me that they don't have any Vivo boards. Could
Yeah,
I get it tomorrow?
Yeah, I can bring it in. So we have a lab in the afternoon from 2 to 3:30, 4, or 4:45, whatever. If you come in between, say, 2 and 3, you can pick one up tomorrow.
Yes, sir. Thank you very much.
I had another question.
Go ahead.
So I guess you could say like this Friday is going to be in person. So are the next 2 lab sessions also going to be in person?
Yeah, the lab is okayed for in person.
Okay.
And our courses are all online, right? Or,
Just for the first 3 weeks.
all right, cool.
Yeah, then we'll switch to in-person lectures as well for the course. Hopefully. Yeah, who
Hopefully,
knows
yeah.
what is going to happen, but I'm hoping that's what goes down.
Yes, sir.
So this week, there's no actual lab. This is just get the equipment week,
Th-
and then next week they start.
That's right. This week is lab 0. It's get your kit and solder your board. Yeah, and you know, if you want to do it at home, that's fine. You don't have to do it in lab.
All right, thank you.
I have one question.
Sure, Daniel.
So I work at E-Controls and we solder boards all day long. Can I bring some of that stuff like the flux and the wick
Yeah.
and all that stuff to help me with soldering?
Sure. Yeah. You shouldn't need solder wick. If you make a mistake, the solder wick is not super effective for getting the parts off the board. It's better to have a gun like, I'll show you, something like
One of the guns that suck it up.
yeah, like this. So this one actually has a little switch that you push. When you push that, a vacuum pump turns on, and you can see this has a hole in the end, and it actually sucks the solder off the pin. And it takes a little bit of practice to make it work, but you put it on, you get everything hot, and then when and liquefied, when you suck it up, it literally sucks it in. And even then, it can be a bit of a pain, but usually that works. And then if you want to get it completely off, if you have a then you can also use the hot air gun, which blows a stream of hot air. And if you have to take off like the CPU chip and you want to melt all the pins, then you can do that. This is what the boards look like before we put on the surface mount parts. This is how we get them. We design them and then we get them from China like this. And then we have a stencil that we squeegee solder paste on, and it puts a little bit of paste on all the little spots. And then we pop the parts on with a pick and place machine that precisely places them in the right location. And then we put it in the reflow oven and bake it for about 7 minutes with a specific temperature profile. And that causes it to all the parts to be soldered. And so we made like almost 80 boards in one evening. So with 3 or 4 students and myself.
All the surface mounted devices will already be on the board. We just have to do the through holes.
That's correct.
Okay, thank you.
Yeah. And I don't have a wave solder, so there's otherwise we could expedite the through holes, but we don't have that handy. I've thought a lot about trying to figure out how to get one, but they're like $100,000 kind of stuff or something like that. They're very expensive. Okay. Let's see. Any other questions on that?
Just to clarify, can you repeat some of the recommended times and dates to swing by?
Okay, so this Friday, if you can come in from 10 to 3 to pick up your kit, and hopefully come with $10 in change. Well, the $10 bill would be ideal. If anybody is strapped for cash, you can go ahead and we'll give you the kit. Just you can pay later, or if you never have the money, you can not pay. It's not that big of a deal. But I don't want anybody to not come because they don't have the money. If you don't have $10, just come. We'll give you one. I spend about $10,000 a year on stuff for my courses, so $10 is not a big deal, one way or the other, and so it's okay.
And on the syllabus, it says an extra $1 as well.
No, just $10. If I have the parts bin sell them, they may have a 50 cent or $1 surcharge just to, so they can do events with pizza. They like to make a little money when they sell stuff. But yeah, 250 for a MyDeck. Yeah, I bought one too. I know they're kind of expensive. Yeah, the reason we can do these cheap is because we make them ourselves, and I buy the parts. I buy the parts on eBay from people who are have excess parts and they want to get rid of them. And we only spend a little bit of money on the parts. We do have to buy the chips, and the chip is about $1.40, something like that. I paid a little more for these because the inventory was down, and I had to buy more expensive chips. They were like $1.50 or something. But anyway, most of the parts, and I buy them, several hundred at a time. I had the headers we had made up. I put quotes on Alibaba and had a company manufacture them to our specifications. And they, when you buy, I don't know, several thousand of them, they give them to you at a good price. So we say we definitely, the boards, I don't think we have more than $5 in the boards. The actual printed circuit board, the printed circuit board itself, it's about 50 cents. The chip's about $1.50. So all told, those are the most expensive parts. The switch is kind of expensive. It's probably 20 cents. And then the rest of the stuff's pretty cheap. So when you add up all the parts, I used to know exactly, but with the surface mount parts, I have no way to figure it out, because when you buy a Rio, you buy 3,000 of them or 5,000, and it's hard to figure it out. Okay.
So can you repeat the room number for that again?
Yeah, so it's in the syllabus, it's on ASAP, but it's EB 020422.
Thank you. Oh,
Yeah.
and one last thing.
Sure.
So on the syllabus, I noticed that the dates for the course schedule and stuff like that starts with 1/19.
Okay, let me see what let me share the syllabus. So I think I have it pulled up here somewhere. It's down. Yeah, so where were you looking, Stanley?
The course schedule.
Oh, down to, okay, yeah, the course schedule is down here. I kind of didn't get to this. Comes right after the Roadrunner Shield there. Okay, so what's the question?
If you look at I believe the numbers on the left side, what are those?
Those are the dates. August 24th.
Okay, so 1/19, 1/21, so that would be January 19th, January 21st.
You're looking at the one I'm looking at?
No, sir. There's a different one that's posted.
Okay, yeah, I haven't updated the one on I thought I did, but I guess I didn't. You're looking at the one off of the web, off of Blackboard?
Yes. Well, I printed it, but yes.
Yeah, okay, so that was last spring. So I'll put this syllabus on there. I didn't realize it. I thought I did, but must have screwed it up. So yeah, I'll get that fixed. Yeah, no problem.
In addition to that, I noticed that there are some, I believe it's for this course. There are some assignments from last semester that have been posted.
Yeah, so okay, a couple of things. So there's about, so the to get everything loaded in, you can't really start too far ahead because they don't make the Blackboard files available, and then you have to copy courses. And anyway, so you don't really have a lot of time to get all those dates straight. And I especially didn't have that this year. So it probably takes me the rest of this week and the weekend to go through and fix all the dates and all the visibility. So like the quizzes associated with the video lectures, I'm probably not going to, I haven't decided whether I'll have you do the quizzes or not. I may just not bother with that, but I might do it too, because I don't know. It's a nice little feature. Gets you used to answering the questions. So I may still have you do the quizzes, even though the lectures will be done live. But I haven't updated any of those dates, haven't updated the turn-in homework dates, haven't updated, apparently I haven't updated the syllabus on the syllabuses are all on Blue Book, but I maybe on Blackboard. I thought I had done that, but I guess I didn't get it done for all of them. Anyway, I'll do all that. I'll get it done eventually. It just, it's tedious, and it just takes, it's super boring. So of course I hate doing it, but I'll get it done eventually. But yeah.
So you just said the lectures will be done live, but I noticed in the syllabus it said that.
You're looking at the last one.
Oh, I see. Okay, that's why I was confused.
Yeah, right.
Okay, thank you.
Yeah, I'll fix the syllabus. Maybe I'll do that right now.
Okay, and I just wanted to make sure that like all the assignments that I've gotten notifications for saying that they're overdue are not going to affect my grade.
Yeah. Don't panic. There'll be plenty of time to panic later, but not now.
Okay, thank you.
Yeah. Okay. I'm gonna change it right now. I thought I did. Yeah, I updated that. I don't know. Something went wrong. All right. So we'll do that.
Hello, doctor.
Yeah, go ahead.
First of all, hope you had a good summer, and I see you again. And also, I'm looking for soldering iron kits on Amazon.
Okay, let's do that.
Yeah.
So now this syllabus is correct. Okay, so take a look at that one. And also this is for the office hours, but that's not the one we're on now, right? But I'll do this at 12:10 every Monday. So if you need to come to office hours, just click this link. And those are all the Monday dates. Okay, so let's look on eBay. So I was just looking at that. Well, I just bought this. Okay, so
I was more so thinking Amazon.
Okay, you can do that. I think I have it on Amazon. Where did I do with Amazon?
There's two that I'm looking at when I typed in soldering iron kit. There's one that looks like to be in some sort of carrying case, and then there's the kind that is that has the dial with the little digital reader.
I'm gonna search for solder station. I think it works out a little better. Okay, so here, this is kind of the, well, that's a knockoff. So you can see there's a kind of a pretty big range. But the one that this is like hot air and solder and all sorts of stuff for 119. Here you get, all this stuff for 54, for 39, you get this with some extra tips. The one thing it's good to do is make sure you get one that has changeable tips. Now, the problem is, like this is Bacon solder station. I've never heard of that. So chances are when you want to go find tips, you're going to have to look like you're going to have to do some serious searching. So what I usually do is I like the Weller. It's not the greatest. There's the Weller. Now, so this is a standard WLC 140 watt solder station. Okay, and they varied. So this is 42, $40. The thing that's nice about this, so you do have the ability to change the temperature, but it doesn't have a built-in temperature sensor at the tip. So the temperature may not stay exactly what you set it, but you can vary it somewhat with the little knob. Okay, but the nice thing is, and it's not the best design either, but the thing that's nice is these tips are changeable and readily available. There's a little set screw you can see right on the back side. I guess I can't see it. The set screw is right there, right there, and you just loosen that. The tip slides out, and then you slide another tip in. I had one of these for years. It had served me well. And you can buy a whole range of tips, but you can definitely buy more tips. So for instance, if we go back here and we get out of this and we just say solder. Here they are. These will fit that. This will fit that solder station. When you want to find tips for the other one, let's try it. Haven't tried it, but okay, here's one. The MERECE. Now maybe it takes MERECE. Okay, well, let's see. Maybe they do come up. So if they come up, all right, okay, I'll feel better about it. But you should definitely check. So before you spend the $38 for this, and it may be a better deal, I don't know, make sure you can get the tips. And if you can, great, maybe spend $9 and that's actually very cheap. So, this might be a good deal. So, yeah, but search for it and check, make sure you can get the tips. And if you can, I don't have a problem with it. If you can't, then you may want to think twice. Yeah, this looks like it's got some good features. And it looks like you can set the temperature on this one, and it's got a temperature sensor in the tip. I also like the way this goes on. You see, this has a little knurl knob there, and you can pull this sheath off and then slide the tip over. So that's probably a better arrangement. So I would say this is probably a better deal than the WLC 100. It's just that anywhere you are in the world, you can probably get the Weller tips. But
perfect.
What with Amazon and all, this might be a good. And I do like you can argue whether the sponge or the copper Brillo pad, which one's better. I like to have both available. The Weller is set up for the sponge. It's got a sponge here, but the Brillo pad's nice too. And you can get them both in separate things. So you have to put a little water on the sponge to make it work, but it's actually very nice. So yeah, so I don't know. I think you can't look. Both of those look good. So whatever you do, check it out. Do you have to buy one? No, we'll have them at school, but it's probably not a bad idea because later on you're going to do a senior design project, and you're probably going to have to do some soldering. So you probably want to have your own. Also, we have 5 kits you can check out for soldering.
Okay.
And right now we're using them. We got them all broken apart, and we're using them just for kids to solder, students to solder. But we'll probably reconstitute the kits, and then we'll take them to Jared, who's who's the lab manager for the department. We'll take them to his office, and then you can sign them out with your ID card for overnight or whatever.
Thank you very much.
Okay, let me. So it's 2:05. I got 10 minutes. Let me see if I can. So I did want to go over the syllabus just a teeny bit more. So there it is. Okay, so the schedule's at the end, and here's the schedule. And so this I will keep this up to date. So today's 8/24, our first class. I didn't do the pick and place demo. I was going to do a video for that, but I haven't done that. But I will do it. And at some point I'll play a little video, show you what we did. Then I think there is a prereq test online, and you can do this online. I think it's in 2 or 3 parts. And I'd like you just to go online. Let me show you the Blackboard page. Let's see. And so if we go down here, I think it's at the end. So let's see, is it prereq here?
Dr. Morton, you're not sharing your screen.
Oh, sorry. Okay. Okay, let's see, prereq. I know it's here. Maybe I moved that up here. Oh yeah, okay, prereq. let's see, there it is, but. Okay, oh, there. So you click on this folder and then it's in 3 parts. So there's 3 separate quizzes. And that's just to make it easy to grade because it's automatically graded. So then I'll get 3 scores. The first score will tell me about, a little bit about your knowledge of C, C++, a little bit about your logic design knowledge, and a little bit on just microprocessor general knowledge. And that's what ABIT wanted to see. So that's why I broke it out like that. So if you guys will do that tomorrow, that'd be great. I'd like everybody to do it. It shouldn't take too long. It does not affect your grade in any way. It's one of the things we have to do to maintain our ABET certification. And I think, I think you can just do the test. I don't think that it's, let me make sure that, I don't think I had it timed. Yeah, it's always available. So, yeah. So you can take it anytime you want. I think it says display. Yes, make available. Yeah, so you can do it anytime. So if you do that this week anyway, and then I'm supposed to do the analysis and then write a little response to it that goes in my ABIT folder. But this is how we keep our courses certified. And you want the courses certified, let me tell you. So, and we are. Last time we did ABET, we got 6 years certification, and we got approval for the computer engineering degree. So we did great. We look good. We were the best department within the college. So we were good. And hopefully we'll have a repeat performance. And I think 2 years is when we come up again. So. Anyway, so if you guys would do that for me, that'd be great. All right, back to the syllabus. So anyway, so this is the lab, and all the labs are on here too. So this Friday, lab 0, build your board. Next week, blink the LED with a loop timer delay, and we'll talk about that. And then we'll use timer 0, and then we'll do the interrupt, and then the labs will get a little more complicated. But these are all going to be with an assembly language. And then by the time we get here, when we do our touch sensing lab, no, I take it back. I think we maybe only do, I think we only do the first 4 labs in C. And then we'll take the programming test on the 28th. And then in October, we'll do PWM, and we'll control it with the potentiometer. So you'll have to have the analog board. So we'll make sure you get all those parts when you need them. And then we'll do, we'll talk about touch sensing, and then we'll do the touch sensing lab on the 8th of October. I think you'll enjoy these labs. So you'll see we'll read the on-chip temperature sensor. We'll read the MC 9700 on the analog board, the pot, the photoresistor, and we'll print those out through the UART to a terminal window on the desktop or laptop. And then we'll do the LCD lab. I guess we moved it up, lab 10, lab 9, lab 8, and then we probably won't do the KL25Z labs. I don't know. The problem with that is the KL25Zs have gotten expensive, and so maybe we won't do that. All right.
We're only gonna have one exam.
Say that again.
We're only gonna have one exam and the final.
No, so there'll be
The program.
no. Actually, it's a little more than that. If you do there'll be a programming test, and there'll be a written test. There'll be a practicum, and there'll be a final, plus the lab. But remember, your lab grade and your final project grade is basically 50% of the course, and then a little bit of homework and the tests make up the rest of it. So
Okay, and there's a quizzes or no?
yeah, I think I will do the quizzes, and so I'll change all those dates and I'll throw those in, and I'll make sure I cover them so that in the lecture I do cover the information in the quiz. I'll try and take a look at those before I do the lecture. So, yeah, I think I
All
will use
these
those.
yeah.
It'll
All of
be
the
about,
exams will be in campus, yeah?
say again,
The exams will be in campus or will be online?
though I'll be online.
Oh, okay. Thank
Yeah,
you.
I'm gonna, the only one that'll be in person will be the, I might have you write out the programming test. But the practicum will be in person. So that should be a lot of fun, actually. It's we have everybody bring, we have you pair up in groups of 3, and you have to have at least one laptop with MPLAB X on it, and your boards and your programmers. First, you have to show your board is soldered together and it works. Then you have, each person has to show that for their personal board. And I have ways of telling if you borrowed somebody's from last semester. So anyway, so make sure you put your own board together and you bring that to the programming test. And then you have to write a little program. Every group of 3 will have a different program they have to write. And then you have to show that you wrote it and it works. And if it works correctly, then you get full credit. If it doesn't, the worst grade you can get on the thing is like a 70. So nobody's going to BOLO, but anyway, so.
Oh,
Yeah.
I had a question real quick.
Go ahead.
On the other boards that we assemble like later in the semester, is it all going to be like pre-manufactured PCBs, or is it going to be like on perf board or something?
No. The only one you have to put together is the Viva board.
Oh, okay.
So the other ones are already put together.
Sick.
Yeah.
Hello, sir. I had a question.
Go ahead.
Are you going to upload the lectures?
Yeah, this is recorded. I will post it. Yeah.
Okay, thank you.
Yeah. I'll put it in the same video folder. I'll just maybe label it F21 or something.
Sounds
What
great.
what
Thank you
it'll be a YouTube link. Okay. All right. I think that's, I didn't really get to any of the lecture. So on Thursday, I will start off, I'll start lecturing on just the stuff that we're going to cover.
And Thursday,
Okay.
we have to use the same link for the Zoom.
Yeah,
link?
same link for Thursday. We'll use this link for everyone until we're back on campus.
Okay,
So for
these
3 weeks, we'll use these links.
Okay, that makes sense. Thank you.
Yeah, no problem. All right, so it's nice to see all you guys. Looking forward to seeing you face to face and seeing you in lab on Friday. Try and space yourselves out over the 10 to 3 window on Friday. But pretty much all you have to do is come in, get your board, and then if you want to try and solder, we'll try and have enough stations set up, probably over in the makerspace or maybe upstairs in lab in the 3rd floor lab. We'll see, but we'll try and have that set up so there's a good 7 or 8, maybe 10 different stations to use. And then you may have to wait a little bit, but hopefully that'll work well. And it's not a panic. Next week, we'll try and also have some solder areas set up on Monday, Tuesday, Wednesday, and Thursday. So you'll have other times to get your board soldered. And then, of course, and obviously you can always do it at home. All right, let me take a quick look at the chat to make sure I didn't miss anything. Okay, we'll just go through these real quick. Okay, you can hear. How's it going? Good. Yes, get the kit Friday, 10 to 3. It's engineering building, again, 020422. And it's in ASAP. If you forget, it's on ASAP. Yes, you can get it any day next week. I'll bring several kits in on Wednesday, so you can pick it up Wednesday at 2 to 3 in the same lab if you want. But then after that, any day after Friday next week. So next week, Monday, Tuesday, and Wednesday, you'll be able to pick it up as well. Yes, it's EBO 20422. Yeah, I haven't put them on eBay. I'm hoping everybody's in town. If somebody wants me to mail them one, I'll think about it. But I did that last year. It's a real pain. All right. Let's see. Yeah, solder. Okay. Yeah, we will do the lab in person. Everybody thought Blake was correct, but nobody could understand what he said. Let's see. Yeah. Yeah, so there's the stall model, okay. Cool. Good. Yeah. Okay, that looks good. Okay. Okay, so somebody had a question off class before we end. So that was Sean. Did you want to ask it, or did you want it personal or something?
Oh, it was just more so of a personal question, but it's okay. I can ask it now. I remember, I don't know if you remember, but I had emailed you these past couple of days about a time conflict override, and you did sign it, and I
Yeah.
finally did register. And then I looked at the schedule and noticed it was Monday, Wednesday, Friday, which means I missed yesterday. Is there anything I need to know, or is it in person, or is it online? Because I didn't see a syllabus on there.
Oh, so was that for DSD, Sean?
Yes, sir.
Yeah, so the lectures in DSD are 9 a.m. Monday, Wednesday, Friday. But you can look at the ones on Blackboard. They're fairly complete. So if you can just come to the lab, then that'll work. I thought your conflict was with the lab, but it doesn't really matter. The lectures are on the Blackboard. Can you come to the lab? Was that work?
Oh yeah, I can come to the lab and the lectures. The time conflict was with the lab, but I couldn't register for the class
yeah.
unless I had the lab too. So
Okay, that's what I thought. Yeah. Well, just make sure you come tomorrow, 9 a.m.
that's in person, correct?
Yeah, and if you
Okay.
didn't get the link, I'll try and remember to send it to you.
Okay.
You might not have gotten it, but I'll send out a reminder, and you should get it then.
And what's the okay, so the building and the room is EB 20406. That's where I have to be at?
Yeah, but not for 3 weeks.
Not for 3 weeks. Okay, perfect.
Yeah. The labs are in the same as the micro lab, but the lecture, it's probably the same for the micro lab too, but or the micro lecture, but we're online for 3 weeks.
Oh, okay. So then I just need the Zoom
Yeah.
link. Okay, yeah, I didn't get
Right.
that yet since I wasn't there. Okay,
No
thank you.
problem. All right. Okay. All right. We will see everybody then on Thursday, same time. Talk to you all later.
Thank you so much.